Alright guys, welcome to today's video. So what we're doing in today's video is a topic called the atomic structure and the electron configuration and the periodicity of elements. But for this scope, we're going to be looking at just some few questions on them. So the first question here is the periodic classification of the elements is an arrangement of the elements in order of their. So when you're talking of periodic classification, that is how elements are arranged in the periodic table. Now you need to know something, that in the Mendeleev was part of those that contributed to the development of the periodic table. Now when Mendeleev actually did the periodic table those times, what he actually used was atomic weights. Do you get what I'm trying to say? What he used is what he used in order of increasing what atomic weights. But now this question is not specifying whether they want modern or old weight, but they just said the periodic classification of elements is an arrangement of the elements in order of. So it means what they're asking us here is modern. They're not asking us that of old. But if it is that of old, it will be based on the atomic weights. I hope you get what I'm trying to say. But because it is recent ones, so it will be based on what atomic number. So modern chemistry. So we use what modern chemistry. They arrange elements in order of what increasing atomic numbers. So they use what increasing atomic numbers. So that's the answer. So our answer will be option D. So that's just how to answer questions like that. We'll try to reduce this. So look at this now. They said the nucleus of an atom contains protons only, B neutrons only, C protons and electrons, D neutrons and electrons, E protons and neutrons. Now for you to do this type of question, this is how to do it. Let me try to increase the brush size again. So whenever you see a question like this, you need to ask yourself, what is an atom? Atom contains this is a simple structure, although this structure has been proven over the year that it is wrong, but for your level, let me just try to draw this structure this way. Now this is an atom, right? This is an atom, and this is electron revolving around this atom, this nucleus. So this is the nucleus of the atom. Now if you look at this nucleus, you will notice that it is positively charged. Now if they ask you what is present in the nucleus of an atom, nucleus of an atom contains both proton and neutron. And if they ask you that why is it that the nucleus of an atom is positively charged, it is due to the proton, because proton is positively charged. If you look at electron, electron is what negatively charged particle of an atom. Why neutral? A neutron, just like the word neutral, it's actually what a neutrally charged particle is neutral. That's just what you have to know about a neutron. So it means in the nucleus of an atom, in the nucleus of an atom, we have protons and neutrons. Now there's still something you have to know about this thing. Some textbook, instead of saying protons and neutrons, they may say nucleons. What is nucleons? Nucleons is the combination of protons and electrons and neutrons rather. So that is nucleons. So nucleons is the same thing as mass number. So in one of the questions we are going to be doing today, question on this aspect is available. So I'm going to do it for you. So mass number is also what? Protons plus neutrons. They may just ask you in some questions that which of the following does not contribute to the mass number. They will now say proton, neutron, electron. So what will be the answer now? So electron does not contribute to the mass number of an atom. So please take note of all these things. So the answer here is what? Protons, option E. So protons and neutrons. So this you can see what I told you, that they actually are asked. Now before we do this question, let's do this question now. There's something you have to know. So I'm going to teach you that. Now you know something that atomic number is the same thing as number of protons. Please take note of that. What did I call it? Atomic number is the same thing as number of protons. Do you get what I'm saying? Now, you should also know this, that the protons will be equals to electron. If an element is not, if an element is in in an uncombined state, that is, it's not like gaining or losing electron. When an element is in a free state, or let me say when an element is not a cation or anion. So when an element is not a cation or anion, do you get? But if it's an cation, the proton will not be equal to the electron. So now look at this question. So they now said, if you look at this element now, they just say element X. It means it is not losing electron, neither is it gaining electron. So it means this element is neutral. So it means your electron here, they've given your electron to be 82 electrons. So it means your number of electrons will be equals to what? Will be equals to your number of protons. Do you get what I'm trying to say? So this question, you don't even need to solve any question. So they now said we should find the atomic number, and I told you the number of proton is the same thing as atomic number, and they have already told us that the electron we have is 82. So it means our answer will be 82 because number of protons is equals to atomic number. I hope you understand how I did it. Please, this thing is very simple. Don't let them confuse you with questions like this. So please, it's very, 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 very simple. So the answer is what? Option D. That's your answer. So for some questions, they may just ask you that you will find the mass number. So I think you should not find that difficult. You already know your number of protons to be 82, right? And you know your number of neutrons. You know, I told you mass number is equal to what? Protons, number of protons plus neutrons. You just add your neutrons with the number of protons. So just add it. So what do we have? We have 9. We have 209. So that would be your mass number. So that is just how to do it. So all these things are not hard. Very simple. So look at this question now. Look at this element. They just draw the diagram for you. They said the diagram above represents an atom. A, magnesium. B, helium. C, chlorine. D, neon. Now, whenever you see a question like this, what you just have to do is count the number of dots in each shell. If you look at this is an atom. It has 3 shells, right? This is the nucleus of that atom. So this is the shell revolving around the nucleus, right? So it means the first shell, it contains 2 electrons. So the second shell contains 8. The third shell contains 2. Now, which element has this electronic configuration? So which element has that electronic configuration? So let me start from the back. Neon. You already know that neon is atomic number 20. Please, I want to give you an assignment. If you don't know the first 20 elements offhand, please, it's something you have to go and learn. If you don't know it, go and learn it, because chemistry is built on this. Is like a solid ground. When our teacher was teaching us in JSS 3 or JSS 2 and they are telling us to go and memorize it, we thought they are kind of punishing us. So if you don't know the first 20 elements, go and know them off and know even if you may not even know them off and know what is in 20, know what is in the 18, know what is in 15, know what is in number 5. So know all of them off, and even if you cannot study all the first 30, first 20 is enough. I hope you get. So please so neon, what's the atomic number of neon? You already know that that's atomic number 10. So the electron configuration is 28. Chlorine is actually, this is a topic on its own. So I thought it's part of the things we are going to be doing in the paid class. So if you are interested in the paid class, make sure that you register for the paid class, in which we are going to do all these things in basic. Chlorine is 16. Chlorine is 17. So that's 287. Can you see now? Helium is hydrogen helium, so that's number 2. So that's the electron configuration. Now magnesium is what? 2 2s2. So it means our answer is what? Magnesium. So magnesium is the one with that electronic configuration. So let's go to the next question. Now look at this question. They said 1s2, 2s2, 2p6, 3s2, 3p6, 3d7, 4s2. Some of you are not used to something like that. It should be 2s2. It's because I don't know how to type in that way. So just like this. So don't be confused. So this is what I try to write. So 3d7, 4s2. Let me teach you something. Now you need to know that when we are under something like this, we have something we call SPDF configuration. So when we're talking of SPDF, in which is the process in which you like write the electron configuration of elements in SPDF notation. Now you need to know that S, the maximum number of power that S can carry is 2. For P, you add 4. The maximum number is 6. For D, the maximum number is 10. For F, the maximum number is 14. Right? And even it's part of a topic we're going to be doing. I'm going to teach you how to write in the paid class. I'm going to teach you how to write the electron configuration in the paid class. So please try to register for the paid class to get access to all this type of teaching, because we do them like side by side. So look at this now. Now look at these elements. Now before you can proceed to other elements, you must be able to finish up. That is, you need to fill every one of them to the maximum before you move to the next one. But we have some elements called transition elements. So what did I call them? Transition elements. So what are these elements? They are the elements that have partially filled, they have what? Partially filled d orbital. Now don't forget what I told you here. I told you that the maximum number d can take is 10, right? Look at the ones that comes before d. For p actually was able to accommodate up to 6 maximum. But when they get to d was the one that destroyed everything. If you look at S was able to, there's no way you have 3s1, then you move to 3p6, right? All of them, they complete their maximum. But if you look at this type of d, it does not complete it. Normally it should be 3d10, but this d is not complete. So you can see that orbital is what is partially filled. So whenever you are seeing partially filled orbital in a particular element, it means that element is a transition element. So those are part of the things you have to know about them. So we have other characteristics of transition elements. They have variable oxidation states. That is, the oxidation states can be different. Look at iron, for example. Iron is also a transition element. It can occur in iron 2, it can occur in iron 3. Look at copper 2. Copper can be in copper 1. It can also be in copper 2. So, and so on and so forth. Another thing about them is that they form complex ions. They form what? Complex ions. So they form complex ions. Another thing is they have what? Catalytic ability. That is, they can be used as a catalyst. So for example, look at vanadium 5 oxide that we use in contact process in preparation of tetrasulfate 6 acid. So look at another one here. We have finely divided iron that we use in HABA process in production of ammonia. So all those things like that. So they are not hard. Nickel too. We use nickel in addition reaction. That's in organic chemistry. So all these things we are going to be doing them in the paid class. So that's why you have to register for the paid class, and the price is not something that is so difficult. So what's our answer here? Our answer is option C. So transition element. So now the last question for on the list for today, in which we are going to be looking for, we're going to be solving a particular question. So look at this now. So let's do the first question. So they said, given the mean atomic mass of fluorine prepared in the laboratory to be 35.5, so that's our relative atomic mass or mean atomic mass, anything they call it, that's our 35.5. They now said, assuming that fluorine contains 2 isotopes, that is, the first mass number is, they said it is 35, The second mass number is, I'm talking of this, they say it is 37 because they said mass numbers. So we assume one of them is 1, we assume some of the other is 2. They now say what is the percentage composition of the isotope of mass 35. So it means they ask us to find the percentage composition. So that would, let's represent that one with alpha 1, and let's represent that of the 2, the 37 with alpha 2. So what we are looking for mainly is alpha 1. So how do you now do question like this? Now you need to know this. The formula for relative atomic mass is mass times the percentage composition of mass 1 plus mass times relative abundance of that is percentage composition of the elements 2, isotopes 2. So let's do them now. Now if you look at this question, we already know the relative atomic mass, but we don't know the two of them. Now, how will you be looking for two things that you don't know in a particular question? So what we are going to just do is that, since you know that this is a percentage, so it means if you have alpha 1 plus alpha 2, it's going to give you what? 1, right? You know what I'm trying to say is, in your question, if you get something like 25 plus 75, I already know the answer. So, but don't let me be saying it. You know, it's percentage. It's percentage, right? 100%, your answer will be 1, right? What I'm trying to say is, you know, it is percentage, so it is 1. That is, if you get 25% now, it will be 25 over 100 plus 75 over 100, right? 25 plus 75 100. What do you get again? So 1. So that's what I'm doing. So it's not as if I'm doing magic. So that's why I'm doing it that way. So please, I think you understand what I'm doing now. So now what we are going to do now is, what are we looking for? We want to look for what? Alpha 1. So let's advertise alpha 1. So what we are just going to do is, we are going to represent alpha 2 with alpha 1. So that will be 1 minus alpha 1. So in place of alpha 2, what are we going to be using? 1 minus alpha 1. So let's do that now. So what's our relative abundance? So that's 35.5. Relative atomic mass. What's the mass one? That's 35 times alpha 1 plus 37 times 1 minus alpha 1. So what's our 35.5 now? Is equals to 35 alpha 1 plus 37 minus 37 alpha 1. So let's do that now. Bring this to this side. So what do we have? We have 35.5 minus 37 is equals to 35 alpha 1 minus 37 alpha 1. So what do we have? Minus 2 alpha 1. Anything else? So we have minus 1.5 equals to minus 2, sorry, minus 2 alpha 1. So divide both side by minus 2, divide both side by minus 2. So we have alpha 1 will now be equals to minus cancel minus. So you know 1.5 is what? Okay, let's just say 1.5 divided by 2. I don't want to use calculator. We have 3 over 2 divided by 2. You know 1.5 is the same thing as 3 over 2, right? 3 over 2. If you divide it, what do you get? 1.5. I represent 1.5 3 over 2. So those are the methods you can use if you don't want to use calculator. So 3 over 2 now will now be times 1 over 2. You know, when you change division to multiplication to become multiplication. So to because reciprocal of this 2, so it is 1 over 2 like that. So we now have 3 over 4. So what do we have like that? Now what's the meaning of 3 over 5? 3 over 4, that is 0.75. Now if you look at this question, what they want you to do is, they want you to express your answer in percentage. Now you can see what you get now. We got 0.75. So it means the second one will be, if you want to look for alpha 2 now, to be alpha 2 will be equal to 1 minus 0.75. What would that be? 0.25. Now look at it. It means if you want to represent this in percentage, just multiply it by 100%. What do we have? 75%. So that's your alpha 1. So it means therefore percentage composition of the one with mass number 35 is what? Is 75%. So that's the answer. So our answer is what? option D. So this is how to solve questions. That's how to solve what questions like this. So you don't need to really wrap your brain and start running away because of a very simple question like that. So please, whenever you see questions like that, don't run away. It's a very, very simple question. So if you want to learn more about topics like this, well, it's part of the things you're going to be doing in the paid class. You can register for the paid class. So answer is option D. Thank you for watching. Bye.